Hey folks, Sebastian from Madrigal here. Today we're going to look at tire tracks and also get into the data export pipeline for the Basis engine a little bit. So, as you may have seen in previous videos, vehicles in Project Slide can leave tire tracks on the ground. So, they're a bit faint, they can be a bit difficult to see sometimes, but every wheel of every car get to leave tire tracks on the ground currently. So if we do something like this where we sort of slide around the place, you can see that each wheel can leave a trail behind. And that same system can also be used to place so-called static tire tracks in the level using the level editor. And so as you drive around like this and you leave tracks on the ground, those tracks won't stay around forever. They will sort of fade away with time. But here, for example, you can see that we have these tracks here that are seemingly ever present. And these tracks they're rendered using the same system as the dynamic tire tracks, but they're actually placed using a system in the level editor. And this system hasn't been around for very long, the one that allows you to place these tracks in the level editor. It's only been around for maybe a month or so. And I've only really used it in a few places. So mainly this road here, and there's a little bit of there's some tracks up here, as you can see on the ground as well. But I haven't really been super happy with the system so far, and I'll show you why. So let's go into the level editor. And we'll let the level load. I've actually fixed this UI freezing already, but I haven't got the latest editor version on this machine currently. Anyway, while we let the light probes render, we can go here and have a look at the tire tracks. So we're in the so-called valley portion of the level currently, and this is the only place that has tire tracks. If you select one of these guys, you can see this line appearing. It's sometimes kind of buried inside the terrain, but you can see that it's actually a continuous line. It goes all the way to around here. And this is the tire track. This is the statically placed tire track. And we can go here and we can unhide its control points. And if we unhide the control points, we can then move them around. And you can see that the tire track actually moves around with it. And what we're doing here is that we're essentially, take this box here, we're essentially having the path for the tire track be generated so that it smoothly runs through all of these points. And the tire track system then generates a tire track that runs along the spline. And you can do some pretty funky things by just adding another point there and having the path run through. So now it does sort of like a pretty tight. I don't know what to call that. Creates like a hairpin thing here. So you can do some pretty interesting things with these tire tracks. So why haven't I used this system more? Well, there are two problems currently. Previously, or shall we say up until this point, you've had to actually create every tire track with a separate spline. And that can be exactly what you want. It can be very let's just undo all of that. It can be very, very handy and very flexible to do that. But tire tracks typically come in pairs, or even in quads, in four tire tracks or more. But at least typically in pairs. So I have like the front of the wheels follow a spline, and then the back of the the front of the car, the front two wheels of the car follow one spline, and the back two follow a slightly different one. And so that has been kind of tricky to do with the current system, because you have to like set up a spline for each one of these guys. That also means that we've had a lot of data here. So this is just one tire track. It has like that many waypoints. And here's another one. You can see both of them now. They each have around 20, 30, well, 25 waypoints. So a lot of data just to get like a tire track to show up. So I think I've solved essentially both of these issues by creating a new option to the tire track. So let's have a look. Let's go here. This is the Canyon. This doesn't have any tire tracks yet. And we can filter this. So we have a static tire track like this. And we have these tire track points. And actually we want to make that the parent now. So let's put a tire track here. And I'm double clicking, which I shouldn't be doing. Yeah, so here we have the tire track. It's not super visible, but you can still see that it follows these two points here. And we can make it it's probably wide enough. So there's this new option here, single track, which is on by default because that's the way it used to be. But you can actually make it have two tracks. And now with that you can also adjust the distance to do something more if you want to. And the distance should probably be more than 2 actually by default. But now we can just clickety click away, and we'll get these tire tracks that look like 2 wheels have followed them, something like this, and they keep like roughly the same distance. You can see this is a slightly angled here. We can actually just reduce the lookup table sample distance here, which should make them a bit smoother if we need that. So now we get a pretty smooth path. And so that's part of the solution, shall we say. Now we have just half of the points here, so we actually get rid of like half of the data, essentially. We can still, if we want to, we can still make this a single tire track just by ticking this box. But most of the time, I think we'll actually want multiple. Right. So that's one thing that I wanted to get done. What was the other problem? If we go here to the static tire track component, actually before we do that, let's have a quick look at the game object type. And where did my window go? Hello. Went somewhere off screen, it would seem. There we go. That was weird. Put that there. All right. Let's look at the blueprint. And is it maybe graphical blueprint? No. Maybe. Oh, it's in here. Right. Okay. So a static tire track. It has a curved path, and that is this yellow line that you see here. It's just a essentially a path a Bezier path that's sort of fitted to run smoothly along these lines. You can even see the control points if you really want to. You can't actually modify them like this because it's set to run through these points, but this should give you a pretty good idea that this is like a cubic Bezier path. All right, so we have that, and it's created only in the level editor. That means that it's actually not created at runtime. When the game starts, that component is left out. We don't need it anymore. What we do need is this static tire track component, which is created in the level editor like before, but it's also created on the client. So that essentially means like in the game on the client side. And Basis is a client server engine, so you always have a client and a server. You can have multiple clients if you're running in multiplayer mode. But anything that you want to be graphical, visible on the screen, so to speak, you want to make it exist on the client. Okay. Then we have, I think, is it gameplay, perhaps? I don't actually know. Let's have a look. Where's this point? So it's common. It's common tire track point. So it's here. And this is actually set to be editor only, and that means that this whole object doesn't exist anywhere except in the editor. So that means that no matter if we have this client server, have this transforms here to be created on client and server, that doesn't really matter because this whole object is just left out of the export of the level. I mentioned before that we actually have many objects here in the level in the editor, but some of them get left out of the actual game. And this tire track point type is an example of one such object type that just no matter where you put it on which layer, no matter how much you try to actually load it in the game, this object is never gonna end up in the game. That's how you can sort of limit your number of objects that you have in the game. And the only other thing that we have here is the mesh, and it's this actual thing with a TT to specify that it's a tire track point. I just had so many of these waypoints that I wanted a distinct mesh for this object type to make it slightly easier to see what's what. Right. Okay. So what's the whole problem then? Well, we have this static tire track component, as we already looked at. And if we go and have a look at that class, or that component, it has some new things, as you can see. I've modified it, and it's because we have this second tire track ID now. And when we have the object created, if you are in the editor, then we get a pointer to the curve path component, and that's because, like we saw, this curve path component is actually created in the editor, so we can do that. We can do that, and then we can call build. And what build does is that it actually gets the curve path from the curve path component, and it prints a warning, or an error rather, and returns if it can't actually build it, just to let the user know that, oh, you actually need a valid curve path to do that. And then we de-init it, just if we had like a previous one, and then we init the tire track. So let's go back to the object created. If we're not in the editor, so if we go into this else here, we use something called the level data block manager. And this is where we actually get into the whole data export pipeline. So objects such as this curve path component, you might be wondering, how is this component useful if it's only ever created in the level editor? And the reason is that if we go to curve path component, and we go down to its export method. If we can find it somewhere. Here we go, export level. So what this does is that it actually gets the level data block manager and it adds a block, if that block doesn't happen to already exist, with a given name. And the name in this case is typically set to be the name of the component. So this guy, during the export of the level, the component knows that it's not going to be available at the runtime, but we can still have it export its data to a level data block. And so that data is then read-only data that the game can use. And the static tire component knows that it has in the level editor as its body in the same game object. It has one of these components because it has actually gotten the pointer to it here. It knows that it actually in the game there is curve path data available at the path of this curve path component. And that path is stored here in curve data block name, which is simply just a string. So in the game, not in the editor, go to else, get a reference to the block manager, and if it has the named block with the curve data block name, you can just create a new curve path and deserialize it, getting the chunk out of that. And yeah, the curve path is no longer editable. This is constant data because the curve path component actually has gone away. It's no longer available, but the data it exported is still there. So then it can use the same init tire track method that we used before to create the tire tracks. And as we can see, it is indeed the same method as we call in build. Okay, so what do we do in init tire track? Well, we use the tire track renderer, which is a special system for actually rendering these guys. And if we have a single track, then we begin one static tire track. If we have two, then we begin two. And then we start actually sampling this curve path at different points according to the settings that we've set on this static tire track. And we use this add point to static tire track to just to add those points, and then finally we end them. And this is all fine and good, except that the way we actually do this is by using the render scene and casting a ray downwards, so minus unit y, against the terrain. So when we have the where should I go? I should go here, and I should go here and here. Let's disable that. So we have this curve path here. I can actually bring it up ever so slightly by moving this up, and it should be visible all the way through. Well, almost all the way. Anyway, we have this path here, and let's say that we have just a single track for now. So what we do is we cast rays like downwards, like down from down there or from up there downwards against the terrain, and we get at each point that we're actually sampling, we get for example here we get the normal, so that we can actually angle this thing nicely, and etc. etc. And we do this even when we're loading the game, which is kind of silly because those things are not going to change after we actually build the tire track. We will still do it even in the game. So what I would like to do is yes, what I would like to do is go here and have this ray casting actually be done at export time. And then we could simply pre-package all of this data and export it as part of this static tire track components data and read it back at runtime. And we can get rid of these hundreds and hundreds of raycasts that we're now doing during the loading of the level at runtime, and simply just read them out of the level data block, and that'll be that essentially. So what do we actually need to do here? What goes into one of these points? So it has the ID, and that just tells the tire track renderer like where do we actually want to which tire track do we actually want to add a point to. We have the position and the movement direction of the vehicle at that point. We have longitudinal and lateral slips, ground normal, and the alpha value. So these slips actually they allow us to make the tire track look a little different depending on if we are actually if the wheel is slipping there. We're not really using them for the static ones, we're only using them for the dynamic ones, so that's why these are just 0 currently. Right, so this should actually be pretty easy to pre-package. So let's go here. And as the first private thing, we'll add a tire track point. I think that's, yeah, point to static tire track. So tire track point. And we'll want to have vec3, so position. We'll want to have vec3 direction. Then float, so long slip and lat slip. Oh, let's add them there, even though we're not currently using them, because we might want to use them later. Normal and alpha. Actually, yeah, let's just take them out. I'm pretty certain we're not going to do that, so I'll keep them there as commented out, just as a sort of documentation for myself that yeah, I considered those and then I took them out. Right, so then we need some place to actually store these guys, and I think a vector would be pretty good, except of course we might have a second track. So do we want 2 vectors or do we just want something else? I wonder. So we have a vector of tire track points, track points. I think we'll add a second one. I think that's the most easy way. We could like keep track of how many points there are for the first track, and then consider the rest of the vector to be the second track. I think this is actually just the cleanest way to do this, with very little memory overhead. All right. So now then, what we want to do is we want to init this track a bit differently, depending on how we actually if we're creating it in the editor or in the final game. So currently we've run this same init tire track, the exact same code both in the editor and the game. So maybe what we'll actually want to do here is move this raycasting and all of this business to the build function, right? And that means that we'll actually no longer need to do this getting the curved path at runtime, because that all of that business will be editor only. So if we go to build, we have the init tire track, and that's probably fine, right? And that's actually just removing those completely. Yeah. Okay. Yeah. So what we'll actually want to do here is take all of this and move it elsewhere. So just take that away and put it there, and just comment it out for the time being. We'll deal with that in a second. And I think we can move most of this stuff into this if now. So we have like to do fill. And actually, no, we don't want to do it like this. We want to make a second one here. So if we're not a single tire track, then we do the second one there. So we'll always do at least one, right? Even if we're just a single track object, we'll do one. And if we're not a single tire track, we do the other one as well. So we have this thingy here. If you are a single tire track, you can set whether or not the first one is supposed to be a right side tire track or a left side tire track. So let's do is right, and we can do it. If we are a single tire track, then it's set by this boolean. Whoa, doing stupid things here. Like so. So if this is just a single tire track, then whether or not it's the right side, so essentially a tire track left by the right side wheels of the car, that's determined by this boolean here, which can be set in the editor over here. But as you can see, if we untoggle this, then that thing goes away, and instead we get this distance between the tire tracks, because then it's obvious. Okay, this is the left side and this is the right side. And so in that case, this will be false. We'll use this false here, and then the second will come in, and that will be true. So the right side. That should be fine. Okay. And now we'll have, at this point we will already have loaded the new points. So this will be tire track point p in tire track points, right? Okay, let's try track points, yeah. Track points, and we'll want that. So let's see. So this will be, the ID is of course tire track, track ID, and position is p dot position. This will be p dot direction. Then we have 0 0. Then we have p dot normal and p dot alpha, like so. And then we're done with that one. And then we have the second one, second tire track, and we'll want to apply the second track points for that one, right? And let's just put these things together so that they belong together, so to speak. Let's build that, and that should build. Except, of course, it doesn't, because it can't open the file because we have it open in the editor. We might as well just unload the engine here. So, like so. And now it should build. Yeah, we have some warnings there. I should probably look at that. But yes, for the time being, pretty good. Okay, so that works. And now, of course, if we run it, we won't get anything because we have this thing here that we've commented out, and indeed, which doesn't even work. But the build already has this curve path, and it just errors out if we don't actually have a valid curve path. So what we want to do here is clear the point vectors, like so. And here we want to actually, oh no, not that actually, we want to get rid of this, right? So we'll do a track, tire track point p dot position. That is this terrain ray cast result hit point. So that's where the ray hit. Direction is just direction. And normal is this thing, hit point normal. And alpha is just alpha, right? And then we can just track points dot push back p. So rather than adding it directly to the static tire track, we just push it to the track points. Like this, and we can do the same thing here. And we can do even the same thing here, except of course we want to push it to the second track points. All right. So what we're doing here is that if we're in a single track, then we're sitting on top of the spline, and we can just use the ray as we have actually initialized it here. But if we're not, then we actually need to move it off to the side. And that can be done by using the cross product of the direction with unit y, so upwards. In actuality, we would want to use the normal of the terrain, but I'm cheating a little bit here and using just the world up vector, because no one will be driving on any walls anyway. So if they do, then those tire tracks are going to be completely messed up anyway. So we move it off to the side, so we have the ray start, and then we plus the perpendicular vector, and this is where we use the the track pair distance. Okay, cool. Now we should actually have it. So if we're in the editor, we call build, and we call build also whenever something changes, or you know, I don't even remember. Oh, the path was updated. Yes, yeah, okay. Yeah, so this is a message which gets sent by the curve path if it determines that the data was updated for the curve path. And it checks like, okay, is this actually my curve path? And if it is, then it calls rebuild. So it gets the curve path, it clears those vectors that we added, and then it does this whole semi-heavy thing here, where it goes through and runs all the raycasts. It de-initializes those tracks if we happen to have them, and then it inits them. And initting now just means beginning, adding points, and ending. So this should be good. Let's have a look to see if it works. And I didn't save that funky one that I created here, so it's actually not going to be visible. But we should have these other ones here, I'm pretty sure. And yes, it looks like they work. And if we go here and we take one of these guys. So it's that one, and then we unhide its children. Let's just let the light probe rendering finish first, like so, and we go in here and we select one of these. You can see that it is even updating correctly. So now the editor side is pretty good. It's pretty good. But now, of course, if we let's not save that. If we export the game, we should not actually see any paths, any tire tracks. This might actually even crash. I'm not sure if apparently not. But I'm pretty sure that we won't see any tire tracks here. No tire tracks. And the reason, of course, is pretty obvious. Initting in the game now means getting the curve path, which we don't really use anymore, and then calling init tire track, and expecting there to be points in these vectors. And that's a bit silly because, like, why would there be? We haven't called this build thing, which fills them in. So we need to do something about that, and that is where the export pipeline comes into play. So we need the block manager, but we don't really need this guy. We need it at design time in the level editor, but not at runtime anymore. So how should we actually do this? First of all, we need to determine where to save the data. So the block manager is almost like a mini file system. You have a named block, you give it a name. They need to be unique, obviously. And within a block, you have a number of chunks. So this just has a chunk with the index 0, and it's this curve path here. Oh, actually, one thing that we could do before we do anything else is just get rid of that parameter, because it's no longer needed, no longer used. We don't use the curve path to init the tire tracks anymore. It's only using the data found in the vectors. So like that, and also we can do this. Right. So rather than getting the curve path out of the level data block here, we need to get the level data block for this object itself. It needs to somehow like determine, okay, where am I actually going to write my data? And if we go to look at the curve path, it does something similar. It has a method here, which is just apparently it's just the name of the object. Okay, it's the name of the object. And that's a bit silly actually, because it should probably postfix this with the component name. So yeah, but yeah, I'm not gonna change this, because this curve path component is used like all over the place, not just by the tire tracks, but by all kinds of animations and whatnot. So let's not do that, but let's do something similar. And let's add a function for that. So we'll do basis string get data block name. And we can just do return get object, yes. Not that, no, get object. What? That's not the get object I want. Oh, it's called get game object, isn't it? Oh, it gets confused because I haven't properly scoped this thing, right? That should be called get game object. Yeah. Get name, and that should be a string, right? And then we can just add some extra things to the end of it to make it unique. So let's do like get name, and that should be the short name if I remember correctly. Oh, that's actually the full name, isn't it? Yeah, it's the full name. Well, we can actually just use the full name then. Don't necessarily even need this. But if we want to change the name of the data block later, then it's pretty nice that we actually have it here. So we can just do get name, and this should return a reference. Yes. So that means that we can just return a const ref from this one. And if we change our minds later about how do we return the name, we can just go here and change this one place. Okay, because we will need to call this in a few places. So we already have an export level, and this basically, what this does is that at export time it asks the curve path component, hey, what is your data block name going to be? It stores it here, and flush exposed properties. That essentially just means that if you have an object that has like these are exposed properties, like this thing here, for example. If you actually change these from code, you need to make the system aware that you've changed them. So this flush exposed properties is just that. And right, so we have the block manager. It's called data block manager. No, what is it called? Level data block manager. Yes, level data block manager. Add block if does not exist. That's pretty good check to do. If someone has already added that, then that's not great. So I think this one might actually assert there is already a level data block. Yeah. So let's actually use that instead, because if someone has already added something with the same name, that's typically a pretty good thing to know about. So get data block name, buffer size. This is like the maximum buffer size. How much are we going to need? Probably not that much even, but we can leave it as it is for now. And into the block we add a chunk. So we add the tire track, the track points, is it? And then we add a second block chunk, which will be the second track points, like this. And we can do if not single track, then we add. That means that I think I actually want to do it like that. That means that we don't even add the chunk there. We'll save like a few bytes of memory if that has any. If that makes anyone happy. All right. So that should be good. Now we have this object exporting data. You can see that it's wrapped inside basis editor included if defs. That just means that like any and all export logic gets essentially the code to do that just gets stripped out of the final build, the build that will be delivered to you, to the players. Right. And now then, and we can, instead of doing this thing, we can just do this. And let's get that into like a string data block name. We don't really use the curve data block name at runtime anymore, so from data block like that, and yeah, we'll get the block. data block name. We've got the first chunk, which is m tire. No, not tire, it's track points. And if we're not m single track, then we get the block's second chunk into second track points. This of course means that you need to know the layout of the data that is exported there. If you try to read something that you haven't exported, then typically you'll get like a buffer overread or something. And oh, what did I do? I did something stupid. Didn't I? Let's see. Oh, okay. Yeah, this is stupid. Right. Yeah, we can't just get a put a vector of these guys there, because this doesn't serialize and deserialize function. That's a bit stupid. However, we can add one. Might be the easiest way to do this. So we want core serializable, right? And then we just make this basis. Oh, we want like public basis serializable, right? And we can have a look at like what does this actually mean. So serializable has a serialize and a deserialize function, right? And just add them here. And this one probably doesn't know anything about the binary stream. So let's add these guys to some place, some suitable place here. Probably just as the last thing. Whoa. So essentially, like the stream doesn't know how to actually read or write one of these guys. So it goes like, what? What is that thing? What is it? It's a vector of what? And if you make it serializable, it will just go like, I still don't know what it is, but I can just call serialize to actually write it, and deserialize to read it. So we can just do put, and we do just all of these guys in order, and stream put normal and alpha. And you might be thinking, well, that's a very verbose and old school way of doing things, and yeah, it probably is. It probably is, but it works quite fine. Yeah, so it's unhappy that I didn't prefix it with basis. So this is actually part of the, oh, I have it running still. 1 second. No, don't need to be there. This is actually part of the game code. Like this is not an engine feature per se. We're in namespace slide here. That's why we need to actually prefix these with basis. Just have a bit of coffee while rendering the light probes. All right, so now we should be able to do all the heavy lifting on the editor side. We're still actually exporting the curve path as part of the curve path component, but we're not actually using it at runtime. And that doesn't really matter. The data is fairly small, and we can always put in a flag later to not include that if we want to. But yeah, so now we have these guys here. They have these Bezier curves. The Bezier curves have already been sampled, and that's why we have these tire tracks here. And Now when we press play, which actually does an export, this is just a normal export, as if we were exporting it to a pack file, but it just exports it to memory and then just loads that straight away into the game. So now we should have those tire tracks there. We do, and they look correct. And now we've done much less work at runtime. In particular, did those hundreds and hundreds of raycasts just to get these guys onto the ground has been kind of silly. And we should have some of them over here as well. Yeah. Nice. Okay, I could almost feel it being faster already, but that might actually just have been my imagination. Okay, so now that we have this, maybe we'll decorate this area a little bit with some of these double tire tracks. So these are still these sort of single tire tracks. So lots of data just to get a single one there. I might actually want to replace those at some point, but let's not do it right now. And yeah, it complains that I don't have a valid curve path. Well, that's because we just created it. So hold on, and you'll get your curve path. We can maybe click to have it drawn when unselected, and we just start clicking where you want the tracks to appear. And then of course we want the double ones, so double tracks like this, and they don't of course need to be exactly in the middle of the road. Probably want to have them a bit further apart, something like 2.7 maybe. We can even have a look here. If we place, let's say, a car number 3 here, is this roughly the width of a car number 3? I'd say it is. It's actually pretty close. So 2.7 is a pretty good default distance. Let's actually just make it 2.7. Here. Yeah, so every exposed property, so in other words, these guys here, the inspector, they need to be put into a so-called exposed property map, which allows you to select default values and set some other things. You can set like parenthood and things like that here with this options string. Right. Okay, so now they're 2.7. That's good. Get rid of that guy. Interestingly, those actually change when we do that. I wonder why. Shouldn't really affect those at all. Huh. Did we find a bug here actually? Oh no, we didn't find a bug. I'm being silly. Yeah. There we go. I'd actually nested the object under the tire track, so it became a point, right? Yes. So so it makes this weird loop. Yeah, it goes there and then it goes back. So yeah, you can use anything as a point. As you can see, we can just move the guy further and it gets these tire tracks. And that was silly. It's because it's a child of this static tire track. Just move it out and it lets go. Yeah. Okay. So tire track point. Let's continue doing this. I'll probably want like maybe, I don't know, three of these tracks or something along this road, and we can have them use slightly different patterns and everything. So we have actually 3 patterns currently. We have this and we have this. This is the small vehicle, number 2, the Lancer. Then we have this, which is the 6x6, which we actually just looked at. And then we have this one, which is, I think this is the heavy cargo trailer tracks. Right, so that's one. Let's maybe do one which kind of ends halfway through. We can actually duplicate that to get the same settings, and then we get rid of the points and we add. Right, so that was now one of those heavy ones. Okay, so we can add like maybe a 0 here, and then start adding. Oh, not that. I want to make that the active parent. Yeah. Okay. Sorry, I'm jumping around with the camera a little bit. So make this. Maybe we can make this like slightly more wild. Just running here past these, and then maybe even like. Oh. Let's actually hide these guys so we don't accidentally select them. And we can even uncheck that one. Right, so the most recent point is that one. Yeah, I think I want to make them sort of end there. Yeah, it runs a little far off into the grass, so let's just make it sort of curve a little bit more here. I haven't really gotten these to look all that interesting so far, but I think this should make it possible to do so. Something like this. And then we duplicate that and get rid of those, and we start with the next one somewhere over here, right? Maybe it kind of runs straight over that. Slight nudge. Almost as if it had more speed than the first one. And they're supposed to go all the way down to the bridge. Like so. And they'll just end somewhere there. We can maybe make the fade a little shorter. So yeah, the tire tracks don't actually show on top of any objects currently. That can be used. It's just a texture that we can sample in any material that we want, but I haven't done it in any other material than the terrain currently. Okay, so how is this looking? I think it's looking pretty good. I mean, at least it's working how I kind of expect it to. So let's add maybe one more, and then I think we'll be quite happy with this video. So let's maybe make this the third type, so that would be index 2, and I want to unselect those. And actually, like, we made these already hidden, so let's make these ones hidden, just so that we don't accidentally move them around. we have these ones here that are actually part of... What is it actually part of? Hauling target. Oh, that's just hauling target. That's not the one I want. This is actually the one I wanted, which is this UI path for the road. I should perhaps hide those as well. But yeah, this is actually what I was referring to. When I have so many of these waypoints here that you can't really see which one is which, and that's why I wanted to add the new tire track point for these tire tracks to make them a little bit more distinct. You can just add any kind of mesh as long as you have the mesh and it has a transform. Actually, as long as an object has a transform, you can use it as a curve path point. But of course, it makes it easier to just see them and move them around if they have a mesh. You can move around objects without meshes. The editor doesn't care. You can't actually select them in the scene. Then you need to select them over here in the list. Not that, but that. Should do something interesting here. No, not that. That looks silly. But then something like this. Is this fun? Is this cool? Something that has kind of come here and turned that way. Maybe that's fun. Maybe that's cool. And these objects don't need to be like sitting on the terrain because we're doing the ray casting. They can actually be just lifted off it, and it will work. But it makes sense to keep them sort of close to the terrain. Yeah, maybe that's interesting. Maybe we'll make another one that starts from there. So yeah, how do we do this? How do we do this? How do we do this? So we can take that guy, we can copy its transform and put him there, and then start going this way instead. Yeah, it almost looks like someone has sort of turned around there or something. We can adjust these later, and of course it doesn't really matter. This is not the most... It's kind of like the grass. It's not the most important thing in the world, but it kind of makes it feel a little more alive. Yeah, something like this. Which one is that? That's that one, right? We want this one. Yeah, we want this one, and then we'll move it slightly further, right? Something, maybe not. I don't know. I don't know. Will fall off. Something like that. Yeah. I think that's good for now. Let's do an export and see what they look like and feel like in game. So of course the loading screen is already not immediate, and it's when we do things like this, when we move actually things away from the loading screen into export time processing, then it makes the loading screen even faster, and that's always a good thing. Right. And having these tire tracks, of course, just sells you on the whole idea of this actually being a road. And I'll probably have to work on these a bit more still, but yeah, this now looks like, okay, someone has maybe parked there and then gone the other way around. And even though this now doesn't look all that different from what we have on this side, we have much more data on this side. And of course, you might want to actually combine the double tire tracks with these single tire tracks to get it even more get it looking even more perhaps chaotic, if you will. I think I had a few tire tracks going up that way. Yes, I do. Yeah. That's an improvement. At least it's a lot easier now to make it so that you can actually make it look like you have two tire tracks. Now that you just create a single one and then tick the box, and you'll get 2 for free. Let's see if I can show you the slip a little bit. So here we have like all the wheels have grip. You see these very sort of distinct lines here from the wheels, and over here we have just like more like a smudge like this. It's a subtle thing, but it can actually help you sell you on the idea that it was actually skinning, because you can, of course, you can just use the handbrake, which means that the rear wheels are just gonna completely lock up. Okay, well, I think we're done for now. Thank you for watching. This was a slightly different video, but covered some pretty interesting things, I feel. And I I like this system a lot, the export data system, because this allows you to just export arbitrary binary data into the game just by creating a new component and doing something like this. Super easy to read, and of course you can read any object's data if you just know the name of the data block and then what you will expect to find in there. You can just read anything, and you don't need to like modify the like level data pipeline or anything like that, besides just creating this small piece of code inside the export level function like this. And yeah, if it is a serializable thing, then you can just add it to the chunk. And if your object doesn't need to export anything, you can of course leave this export level function or method out. And most objects don't need to export custom data, so they just don't have this. All right. Anyway, that was it for this time. Like I said, thank you for your time, and I'll see you in the next video. Bye.